Hope everybody's doing good. My name is Madhukar Krishnarao, and myself with Susan will be talking about Kubernetes networking, gateway APIs, what it means for enterprises, service providers today. Let me start with a quick story, right? Generally, that's how it happens. So, well, the story is not about Kubernetes. It's actually about Susan, because right now she is still at the airport. There was a 2.5-hour delay in her flight. So she's trying really, really hard to get back here on time to cover some of her aspects, but I'm sure she'll be here by Q&A time. Till then, I'll try to kind of cover my part and some aspects of her talk as well. So yeah, that was the story. My name is, as I said, Madhukar Krishnarao. I'm a product manager at VMware. My primary focus is container networking, and I used to do a lot of automation as well. And since my friend Susan isn't here, she's also in the product management org in Google. She's the outbound product manager. She dabbles a lot in Kubernetes and open source, so we go back quite some time. We have been working together for about 4.5 years now. That's how long I've known Susan. So okay, I guess we can get started. Welcome everyone again. Thank you for the time and opportunity to speak. I thought I could start from a high level in talking in terms of the app modernization, what it means, how it's changing, and then kind of go into what I really want to talk about. So when we talk about transformation, right, there are essentially two aspects. One is from a technology perspective. Basically, technology is changing. We need to kind of keep abreast of that. We need to change accordingly. But then the second aspect is what the customer or the consumer wants to do. Not in terms of using a new technology because there is a new technology available, but because they actually want to accomplish something. And maybe there is a better way to do it. Maybe there's a different way to do it. It could be as simple as, hey, I want to go to the cloud. Some of these could be a requirement coming up from the top for a customer. Maybe they just want to deploy apps in the cloud, reduce the cost of kind of maintaining infrastructure locally, whatever could be the reason. So there are kind of two aspects that drive the change and transformation. And this is where kind of Kubernetes fits in. But if you think about it for a second, it's just like any other technology that came before Kubernetes. So initially, all the way back, we had physical servers. A workload would mean you putting those applications on the physical server. You still had compute storage, networking that you had to worry about. Then came virtualization. So again, just that all of the things that you talked about, that I mentioned in terms of storage, networking, and compute kind of moved one level up. But you still had to think about how it's done, what it means to you from an organization perspective. Similarly, when we look at Kubernetes, if I have to really simplify it, you can look at it as a distributed OS on a bunch of nodes. It has an operating system. It's connected by a network, but then it is also providing you a platform to deploy a lot of these applications. Now, a lot of these companies are going through the transformation, but then more and more control is also being given to the application developers or the apps. But unfortunately, the applications themselves might or might not be aware of the infrastructure underneath it. And that's where a lot of complexities arise. So you have these modern applications that needs to be agile, that needs to scale really well. But then you also have traditional infrastructure down below, and there definitely needs a kind of a layer in between who can connect the two. And that's where kind of the DevSecOps comes into picture. Now, if we look at it this way, because applications might not understand infrastructure, but on the other side, infrastructure may or may not understand what the application really wants. So there is this clash from both ends. And in between is stuck all the different personas. So here I'm kind of focusing more on the persona because that's where kind of we come in. I could be an IT operator, I could be a DevOps guy, I could be an application developer, but my requirements essentially kind of fit in the same buckets that I've shown here. Typically, we always thought of infrastructure, or traditionally, we would always focus more on the right side, like the infrastructure part. You provide storage, you provide some sort of networking for your applications to run. But then more and more, as technology progresses, as the transformation happens, the focus is coming more on the left side to the developers. In a way, this obviously introduces complexity, but then once this complexity is kind of addressed and solved, there is actually a lot of benefit to this kind of a transformation. And obviously, in the middle, you have your DevSecOps, but then clearly there is some sort of overlap between all of these layers. As a infrastructure persona, I have to be aware of what my DevSecOps needs. Maybe I need to provide some sort of API capability, some sort of declarative interface where the operations people can say, hey, I want more storage, I want more, or kind of a different kind of a networking. Similarly, the application layer folks can also be talking to the operations, saying that, hey, I want my applications to be delivered really quick. I want updates to happen really well. So as an organization, we need to be aware of all of these aspects and kind of make sure everybody goes hand in hand. Now that again also, now drilling a little bit below that, right, from a networking perspective, what does that mean with all this transformation? So traditionally, we have had these, let's say, ISO standard 7-layer of networking, sure, but what that means is you always had a very clear demarcation from the IP layer. Everything below was infrastructure, and everything above IP was application, right? It was easy to separate this out. But then again, the communication between the two was always in terms of IP, port, if you think about it. Because as a developer, I say, hey, I want my application to be exposed to the internet. Sure. What IP, what port do you want to export, or do you want to expose? That's how the handshake used to happen between the infrastructure and the application developers. Now with modern transformation, things get a lot more complex and interesting. Now, application developers are no longer just deploying applications. They don't have to be aware of IP addresses. They don't have to be aware of infrastructure. They're using templates. They're using all these fancy, cool, modern application templates to deploy their apps, their services in public cloud environments, in private cloud environments, whatever else it's there. Similarly, you have this DevSecOps people in the middle that have to worry, still have to worry about smaller things like DNS, about encryption, about TLS, about conformance. And finally, you still have the infrastructure owners still worrying about the physical underlying infrastructure. Now, because there is still the traditional concept of compute, storage, and networking, you have to kind of look at this from both sides, right? Because applications, as I said, may not understand the infrastructure completely. Similarly, the infrastructure might not be able to give all the answers the application needs. Because from an application perspective, I don't really care where my services run. As a developer, I don't really want to know about it either. All I'm going to say is, hey, I have these services. I want it exposed. I want to scale up. I want to scale down. Maybe Thanksgiving is coming. So if I have my web application, if I'm selling something, I know I'm going to get more load. So just make sure the load balancer can deal with it. So these are the kind of requirements that come in. Now, because of that, as an enterprise, as a service provider, you've got to look at it as a complete solution. You kind of have to look at it as an end-to-end, I like to call it the end-to-end pyramid. Because you always have the infrastructure layer, then you have your kind of Kubernetes as a service layer, and then you have your app layer. And this is where we kind of start differentiating between what each of those layers give us, what each of those layers worry about. So obviously in the infrastructure layer, you have your standard operating system provisioning, you have maybe a virtual network deployment, you have your hypervisor, storage, compute, all of that. And then you have a little bit of L4 load balancing, you have your DNS, you have GSLB. But on top of that, you have your Kubernetes clusters. You're thinking about your L7 Ingress, cluster load balancing, and finally on the top, when you deploy your applications, you then have to worry about, okay, now that my application is here, what about, let's say, TLS termination? What about maintaining the source IP of the connections that are coming in, and then I need to send it somewhere else? The other thing that we also need to remember here is the interaction that's happening between some of these layers. It's not that if I have an application, I have to expose my services to the internet, sure, but I also maybe have to talk to services that are deployed somewhere within my organization as well. So which means that, let's say it could be a shared service, it could be a shared database service, for example, in which case I have to make sure there is a firewall rule open in my physical underlay to allow those packets coming from all the way from my app layer all the to my database layer. So there is both considerations that have to be kept in mind. On top of that, we have the new technologies like service mesh that you want to do, endpoint security, because along with networking, security is a very fundamental aspect that we shouldn't forget about. Traditionally, you always think about security as network security. You're thinking about it from a perspective of, I need to do east-west segmentation, I need to do north-south, I need to create a north-south boundary, great. But then we also have to think about, as and when workloads are now moving into containers and modern applications, we need to make sure we have to think about IDS, IPS, we have to think about endpoint security, what these applications are doing. So here again, if I take a step back and look at it, traditionally, all the problems that we were talking about, we still have to remember all that and then learn from that. So previously, you were looking at, let's say, network flows. You were kind of looking at all of the network flows, figuring out what your applications were doing, what's happening within your, let's say, cluster. Similarly, now that everything is kind of modernized, you still have to worry about what your API endpoints are doing, how those API endpoints are being accessed, who's accessing, what are the roles for the people who are accessing those APIs. So there is a bunch of things you're still worried about, except that the focus has now shifted, or it's been added along with the infrastructure layer. So given all that, now again, coming back to Kubernetes, right? When we are looking at a Kubernetes cluster, obviously the CNI, the container networking interface, plays a really critical part. Now for that, I've kind of listed out a few features, which I think is something really important that we need to look at, especially while selecting a CNI of your choice. Now the first thing that the CNI is supposed to do is IP address management. You can have it can be based on Node IPAM, you can have flexible IPAM management. Sure, that's the number one thing a CNI should be doing. The next thing is networking and security. I mean, that was the networking part, the next one is security part. Here again, Kubernetes, standard Kubernetes network policies, you have to support that. But then standard Kubernetes network policies, right, it's namespace scoped. The scope of a policy is just a namespace, which means that if you have multiple namespaces, if you have services running in a different namespace, how do you kind of secure your traffic between the two? How do you say that my production namespace should not ever talk to my staging namespace? So that's where you need to think about network policies that are more applicable at a cluster level. That way you can isolate multiple namespaces. And as I said, along with just network security, we also have to think about endpoint security, what the applications themselves are doing, how are they interacting with each other? Are they accepting connections from known sources? Are any file transactions that are happening between them really good, bad? So you're looking at endpoint security as well. Great, so we kind of know about networking and security, right? But then now coming to what the infrastructure itself should be providing. So for example, as I said, you could have an application wanting to talk to a database that's residing on a physical database somewhere within your organization. Now, how does that impact our Kubernetes cluster? You need to be able to figure out what the pod IP is. so that you can go and configure those firewall rules in your physical infrastructure and make sure the communication happens. But then pods themselves are kind of very dynamic in nature. They can go down, come up. That's the whole point of having Kubernetes, right? You're not worried about one single pod. You're not trying to debug when a specific pod goes down. So you need some sort of an egress, some sort of a NAT infrastructure, which the CNI, which the networking layer provides. The next thing is, if you're talking about whether you're an enterprise or a telco providing services, you obviously have applications which require multiple interfaces. It could be a simple requirement that you want to separate out your management network, you want to separate out your data path, you don't want to run them on the same network, so obviously you need multiple interfaces. And finally, along with all this, troubleshooting. As it is, I don't know, like if you have troubleshooted networking before, containers just adds another layer of complexity to it. You have to figure out how the traffic flow is happening. You need to be able to do a packet trace. So which means that when you're looking at a Kubernetes infrastructure, all of these aspects also come into picture. On top of all this, now I'm talking about public cloud, private cloud. Maybe you have multiple clusters. Maybe you have 500,000 clusters within your organization. You need a central place where you can manage all of these things. So that's kind of another angle to it too. So yeah, when you're looking at CNIs, make sure it's kind of conforms, or some of these things needs to be taken care of. I just put one example here as Antria. It's a CNCF project. I like it because I contribute to it, so that's why the link is there. That doesn't mean this is the only CNI out there. There are definitely other CNIs that you should look at as well. Now, when we talk about networking, it's not just the CNI, right? Because all of Kubernetes is about services, about exposing those services to its consumers, which means we definitely have to look at load balancing. We have to look about container ingress. Now, when we look at load balancing and container ingress, what we need to look at. Obviously, it has to cover multi-cloud. When I say multi-cloud, it could be multiple public clouds, it could be public cloud, private cloud. So a solution that kind of works everywhere. A solution that has an easy lifecycle management, that can be automated, that has RESTful APIs, sure. And then analytics is a very important part. You really need to know what's happening, how your services are being accessed, how much of it is being accessed. So logging analytics is there. And then there is also a level of security you need to look at. It could be something like WAF, right? Or it could be DDoS protection. So L4, L7 firewall, encryption. So all of this is something that needs to come in at the load balancer ingress level. And finally, as I said, again, visibility and operations. Centrally managed, being able to push policies to all of your clusters. Well, it's the standard story here, which is all great. Again, here, there are multiple load balancers out there that can kind of satisfy all of these requirements. Now coming to an organization which has multiple teams, multiple people with their own favorite load balancer or CNI, which means that now you have an organization where if I am the org owner, I have to deal with multiple teams, each with their own load balancers, each with their own ingress controllers. But still, I am expected to make sure there's a conformance amongst policy about all these things. I need to make sure there is encryption happening everywhere. So clearly, there is a need for something else that kind of sits on top of the ingress, and that's where we come to Gateway API. Now, as I said, Ingress API is great. It does cover everything that we want to do. But then, because there is so many of them, because there are so many options available, we still need to be able to kind of, what do I say, have one common ground which can control everything. So because there are different ingress controllers out there, there are varying implementations, there is no ideal way of sharing it amongst different groups. So July 2022 is when Gateway API was first introduced in KubeCon. And I think it's a great way to look at it and a great way to implement this or kind of fill up this gap. So what does it actually do, right? Now, without kind of going too much into details. So a Gateway API essentially provides you a gateway resource taken from a gateway class. What it does is it can interact with all the routes from each of your service owners. So as a service owner, you can kind of configure your routes to a specific gateway, and you can have multiple of those routes coming in. But now you have a clear separation of concerns. From a persona perspective, I own my namespace. I own the service in the namespace. I am free to implement that service in however way I want. I'm free to use whatever Kubernetes cluster I want. But then, based on HTTP routes, I always use the same one single gateway. Now, that's where like a platform administrator would come in. They would be able to create policies, apply it, but still leave enough control for the namespace owners, for the service owners to kind of work on different use cases. Formalizing this a little bit is what Gateway API does. Now, Gateway API, just like Kubernetes a network policy or a CNI, it's a set of APIs, but an implementation depends on who actually is doing it. So today there is Contour, GKE. I think there is one more E. Anyway, if you go to kubernetes.io and look at Gateway API, you'll get the whole list of implementations there. But they are designed to be generic, expressive, extensible, and role-oriented. What does role-oriented mean? Essentially, it means that you're looking at it from a persona, from a role perspective. It's no longer just one solution. It actually caters to different personas that are critical to any modern app transformation today. So as I said, you have the gateway class. It kind of expresses your load balancing infrastructure, whether it's in GKE or on private cloud, wherever it is. It can give you different types of gateway interfaces. The gateway themselves define the routing configurations, and it's kind of protocol specific. They attach to the routes, which are configured by your service owner. So with this, the platform administrator can easily swap out different implementations. They can try out open source gateways. They can try, as I said, different aspects. But very importantly, it covers quite a few use cases for us. Number one, right? It's a very simple use case where, let's say I have multiple deployments, but I want to source traffic to specific sites, and also, depending upon where the connection is coming from, I want to source traffic to very specific stores. So you can do all of that using your route configuration. So you still have your load balancer out in the front, but then depending upon how you want to do it, depending upon the connections that are coming in, you can configure a HTTP route, saying that all endpoints going to store.example go to let's say service V1, V2, but then anything coming to Denmark goes to the deployments in Germany. Now, even within that, now this control of some part of it going to store V1, V2, and some part of it going to store Germany, and how much of it goes to V1 versus V2, all of that control is still there with your service owner. As a platform administrator, I don't have to worry about it. I don't get to define it, but you still have control. However, as a platform infrastructure owner, I will still be able to enforce TLS. I'll still be able to enforce encryption or other policies that are needed within an organization. Again, all of this is easily YAML driven. This is another use case that I think is kind of cool. Let's say you have a canary deployment. You want to first put it in kind of a A/B testing scenario. You want to have only certain amount of traffic coming in, and then once everything looks good, you want to kind of promote it to production. So you can essentially, again, do all of these things with simple YAML configuration files. The point is that there is separation of concerns amongst different roles, and depending upon what you need to do, modifying it, adapting to it, scaling to your changes becomes extremely easy. So that, I think, is the last slide. Maybe I'll open it up for questions. Yes. Okay, so the question is how will a CNI or work when there is multi-clusters within your organization? Now, when we say multi-clusters, right, there are two ways, again, coming from the top. Either you have the same cluster deployed multiple times, in which it's more like a prod staging kind of scenario, or it's also something like you have specific namespaces given to specific organizations, but then you have a central namespace where all of your common services, let's say DNS or whatever else that you need, is deployed. Now, in both cases, from a CNI perspective, you're still confined to your one specific cluster, but then that is where options like a service mesh gets in, because now if you have a service in one that you want to expose to your other internal clusters, you can do that. You can also look at cluster policies. Essentially, if you're looking at, again, services, my favorite CNI, Antria, has that option, but then there are other ways to implement it. If going back to the first case where you just have prod and staging, or you have different clusters deployed in different, hey, a big round of applause for Susan for making it. Thank you. So going back to the first option of you have multiple clusters deployed. Now there, as I said, CNI has it's still visible to only that specific cluster. You would need another a gateway API layer or some sort of a service mesh layer to be able to manage multiple of them. But typically, from a network security perspective, it's the scope is the network policy scope is still per cluster, but the services is what is talking to each other. So you'll then have to look at APIs, API endpoints, what it's doing, who's talking to it, and you kind of fall one level down, because if you have multiple clusters, you can also leverage a segmentation at the infrastructure layer. Let's say there is some sort of a SDN underneath, which means that you can do east-west isolation at that level too. Yes?
Following up to this question, is Antria trying to do both as with the CNI IPAM single cluster as well as the service mesh?
No, the answer is no. Antria is just an open source CNI based on Open vSwitch. So it just configures OpenFlow in the OVS tables. It does do a little bit of cross-cluster service policy today. They just released it, I think, in version 1.8, but it's not in the service mesh or the gateway API space. So you would be adding the service mesh or the gateway API layer on top of the CNI that you pick.
Right. That would be the composite.
Yes. Any other questions? So I just put the link for Antria and gateway APIs. The best way to kind of get in is to get your hands dirty. So there are community meetings that happen pretty much for every as just like any open source project. There are community meetings that happen. Anyone can join and then contribute and then listen in and kind of see what's coming, and kind of influence the direction in which it's going to. So I would highly encourage everyone to participate that way. All right, I think we are right on time. Thank you once again so much for your time and the opportunity for me to speak here. Thank you.